Hi, this is Ryan Zhang from APAC Service Team. So what I'm going to do in this recording is to demonstrate the OpenShift security features for AI agent. So I'm going to, before I jump into the demo details, I'm going to show you the why we're doing this, what it's for, and then what is included on the demo architecture. So first, this is to address a customer concern of how can I make sure the AI agent running security in OpenShift platform. Usually, this is target for the platform architect or platform teams. They mostly concerned about platform security, like the isolations, the protecting the shared resource, avoid unprivileged access. So it's not included for the business application perspective. Okay, so so what I prepared for this is so let's have a look what is the demo applications. I had in the middle have a two parts running, insecure ops agent and secure ops agent. This is a kind of simple autonomous agent. It's utilize MCP server and also LLM model to be able to do some operations, OpenShift operations. By the way, this you see in the slide, this is my environment running on ROSA, but it doesn't matter. It's running on OpenShift. It just works fine. And so these applications, so I have a agent client can interact with my ops agent, and which is running on OpenShift. It can basically respond to users' requests and generating some OpenShift relevant operations like list pod, create pod. And then during this process, I would demonstrate different kinds of like operations. And then we can apply OpenShift security settings and even the OPA gatekeeper to protecting the system. So there are two dimensions. The first dimension is protecting from the shared resource, the the OpenShift node resource. So you can see that we have on the right side, we have a SCC restricted, which is default. It will be applied to secure ops agent. It should protecting this agent to not able to access the unprivileged resource, the privileged resource. On the other hand, the left side, you can see it's by intention granted privileged access. And also, we can see the blue box, which is Kata container, which is a new feature in OpenShift that providing like micro VM as a runtime, container runtime. So it's a VM level isolation for this agent workload. I will show you the details later in the demo. What is the difference? And then the second dimension of the security is the protecting from the OpenShift API. So from API perspective, one way is that we apply the role-based access to control the service account of the agent. again, by intention, I give a class admin the most privileged admin access for this agent to demonstrate some capabilities that OpenShift can provide it to in regards to the security feature. So on the right side, let's look at this. On the right side, I set up a OPA gatekeeper operator, and then I got the OPA gatekeeper to protecting the OpenShift API server. As you can see, I already applied some of the rules that so whenever either from secure ops agent or insecure ops agent, when they have a API request coming, it will do the check and do the block or allow based on the rules. So that is the setup. Let's jump into the demo, see how it works. Okay, on my right side, I will show you what is involved. So basically, in this demo, we only have a two namespace: agent security to have the agent application, this gatekeeper OpenShift gatekeeper system is hosting the gatekeeper rules and controller. Let me show you. Let me show you this. So as I described, there's an insecure ops agent and a secure ops agent. So let's interact with this. And let me start the logs for both agents. And then it will, after loading the previous log, it will be normal. And on the left side, I had an agent chat client. So in order to interact with this agent, so user can input two agents by specify either secure or insecure and send the request, use natural language. So in secure ops agent, list path. So by default, it will list path in current namespace. So as you can see, this is my agent URL, and at the back end, it will triggering my LLM model, which is inference utilize OpenShift OpenShift AI platform. The model is running on OpenShift AI, and it's triggering all the MCP tool, the LM and the MCP tools, and then get back the result, as you can see over here. So this is normal operations. So list to path. Let me do another operation like list the secrets. Usually, the platform teams do not want those agents be able to access some confidential information. And then for this secure, I didn't specify the secure agent, but by default, it will use the default one. So you can see it was forbidden by who? By the RBAC settings. The service account have to follow the RBAC settings. It do not allow to list this kind of a resource. So that is the first layer that we can apply to protecting the API access. And let's have a look. What about the insecure? Let's say my insecure ops agent do have the cluster admin. So, and of course, it can list the secret. And what if the someone want to modify, update my secret? update secret secure ops agent. This is a secret is already configured in the namespace with password. Let's say admin. Basically, it will also utilize the MCP tool to do the operations for me. And then let's see what's going to happen. First of all, it's access the insecure ops agent. And then again, this was forbidden, but forbidden by who? By the gatekeeper as I designed it. Because for our role-based access, somehow it does have the highest admin permissions. However, we have a gatekeeper to protecting the Kubernetes API. So in that way, it's like a multi-tier of protecting of the Kubernetes API servers. So this is the dimensions of how OpenShift can protecting, blocking the unprivileged, allowed access to the platform, to the APIs. So let's have a look at another dimensions. Let's see. I want to create insecure ops agent. Secure ops agent. Let's say I want to create host path. So I want, basically this is not a typical secure workload, which is trying to mount to the OpenShift node cluster path, host path. So by secure ops, because I have settings for the SCC. So it's a user default OpenShift building secure constraint, context constraint. Basically, it means it's running on secure computer mode. So it will not be able to access those sharing host resource. So this will be well protected. Let's see what's happening if somehow somebody walk around this. Create host path. So by this insecure ops agent, I assume it do have the privilege SCC settings. And then let's see what's happening. You can see from the error message, you can notice that this has been blocked by our gatekeeper, OPA gatekeeper. So that is the whole settings of the settings for this demo that we have a multi-layer of protecting both on the operation system, but also the API servers to make sure our agent can be run secure in the platform. So we notice that this is autonomous agent, so it can do a lot of unpredictable operations. So the secure is very important. Okay, so I'm going to show a quick demo. So I also mentioned that my secure ops agent is running for the Kata container. That is a new feature developed in the OpenShift. So Kata container, let's have a look at this. OC. So these two parts are running on different nodes. For this one, my part was specified using a runtime class as a Kata. So, and then let's say what's the difference. OC I'm going to show this. I'm logging to this insecure, the normal class runtime, which is run C, and I'm going to start a process because this image do not have those a lot of like system tools, but I use a simple tools as sleep to show you the concept. Basically, the Kata container is a VM level isolation for the container process. So it means that each container, it has its own kernel, its own operation system. It do not sharing the same host operation at the host kernel as a normal container. It's more secure, more isolated. So let's start this process. And then I'm going to log into this worker node to show you. Let's see if I can see this process because this is a normal container. So I'm expecting this process will be running in the host level. I just need to search this command. As you can see, I can find it because I'm running this before. I didn't kill this one, so you see 2, but doesn't matter. And the you can see this. You can see this process which is running on the operation system. So let's see the secure one. Because we mentioned that this Kata container has a VM level isolation. It do not share the underlying host kernel, host operation system. Let's do this, use a different command, and let's search it again for this new worker node. Let's see if we can find this process. As you can see, we didn't find the process. This is because it's only existing in the VM level. So by this, oh, I don't have this command. I don't have this command, but make sure you can easily see this process was running on this path. So yeah, so in short, this is a demo that show you that the VM level isolation is more secure to totally isolate the process, the tools running in the system. Okay, thank you for listening.